Well, good morning, everyone. Sorry, actually, my headphones are not working right now. I can't hear you. So let me see if I can fix that. I don't know what's going on. Did it come unplugged? Maybe it came unplugged. Let me check that. No? Well, that's bizarre. Let's see. If you talk, can I hear you? Huh. I should have fixed this before I started. Let me see if I can do something over here. No, I don't think that's broken. So you can't hear anything? Nothing's coming in? Hmm. All right, let me try this. I'm going to turn it off, turn it back on. When in doubt, turn it off, turn it back on. All right, let's see if we can get things fixed here. Let's see, I got to find a switch. Nothing? No sound? Oh, this is terrible. Oh, let's see. Let me ask these people here. This is kind of embarrassing. I don't know why it's not working. Oh, so it's a problem on the Zoom end. All right, let me try this over here. Let's see. All right. Okay, I got to try something out here. Nothing's happening there. All right. Yeah, no sound on Zoom. So, I'm not sure what's going on. So you can't hear anything at all. Let's see. Turn this off. Turn this on. So let me check this over here. So YouTube folks are saying they're getting sound, which means my mixer is working. So then the problem must be trying to figure out where the problem is. Sorry, this is like totally embarrassing because this should have been fixed before I got on this stream. And I should have noticed something was wrong when I put on my headphones and didn't hear anything. But I didn't pay any attention because I was doing something else. So, give me a moment. I'm not sure why it's not working. I mean, unless I just have to like start Zoom over again. Could do that. Let's see. So I'm not getting anything there. But okay, so YouTube can hear music, which means, what does that mean? Oh, sorry, I have to disappear for just a moment. Does that mean, let's see, that's plugged in and that's plugged in? Well, it should be because music is getting into it. This is bizarre. Why isn't this working? Let's see. That's working. I can turn down the music. Huh. No, that didn't do it. Oh. So now you can hear something? Did it go away or is it back? Oh, I know what happened was when I flipped that switch on my screen, it switched over to my internal microphone on my computer, which you don't want. You want to hear this microphone. Otherwise, you get everything else. Yeah. Oh, so here, I'll tell you what happened. Let's see. Yeah, so what happened was I flipped a switch on my screen to change the audio inputs, and it went to my internal microphone on my computer. And then when I flipped it back, of course, it turned it off. But you probably don't want to hear my internal microphone because it's all like echoey and you can't hear me very well. Boy, this is crazy why this suddenly doesn't work. So now the audio is going to go away. Oh, I'll just do this here. Why isn't this working? Okay, how about this? So I take it you can hear me now, right? But it's kind of echoey? Yeah? Yeah? Okay. Okay, so I'm going to set you on something to... sorry the audio is terrible. I'll work on the audio in just a moment. What I'm going to do is I'm going to say, welcome to Computer Science 46. This is System Programming in C. We're good? My name is Barry Brown. I've been teaching this class for, I think, at least 12 years. And this is going to be an introduction to the C programming language. And what I want you to do while I work on this audio problem, I'll turn on the music a bit, is, here, I've got a problem for you to do. I want you to write a program in any language you want. So it could be one that you already know, like Java or Visual Basic or JavaScript, that displays the message, I heart pizza. You can make the heart out of a less than sign in the number 3. Use any language you want. And then what I want you to do is, if you wrote it out on a piece of paper, it's not a long program, so write it out on a piece of paper, take a picture of it with your camera and then upload it to the Zoom chat. Or if you actually wrote it in like a text editor or development environment, take a screenshot of your program and then upload that to the Zoom chat. Okay, so take a couple minutes to do that while I work on this audio problem. And I guess I'll keep the music going so that there's something to listen to. I don't know if you can hear the music. Yeah, I did check Zoom's audio device settings and it looks fine. The problem is that I've got audio coming out of the mixer and then it goes into my computer and then from the computer it gets redirected to Zoom. So I have a piece of software that does the internal routing of the audio. And the problem is I can see on the audio meters that there is no audio getting to that portion of the computer. So there's some disconnect between the audio coming out of the mixer and going into the computer. That's where the disconnect is. So you're all working on that program right now? Okay, so keep working on that while I try to figure out what's going on here. It's not a problem with the audio jack because it's all coming in by USB, but the fact that the audio is getting to the mixer means that the USB is not a problem. So what could it be? I mean, like, I could just restart the computer, I suppose. Let's see, turn this off, turn this on. That's not it. That's not it. You know what I'm going to do is I'm just going to disconnect the USB. I'm going to see if that works. Okay, but prepare for things not working for a moment. Disconnect that. Ah, okay. I hear music. I think we're good. Did we get it? Can you hear me now? Oh, good. Okay, so sorry about that little hiccup. Now I know in the future all I got to do is just unplug the mixer, plug it back in on the USB connection, and that should fix the problem. I don't even know why that even failed. I've never had that fail. So that's kind of weird. Okay, so pictures are coming in. So before I throw these things up on the screen, I want to let you know that I am streaming this, of course, to Zoom. And so there's about 8 of you here, and you're my actual students who are in the class. And I've also, it looks like I got about 10 people who are watching on YouTube. So last semester, about midway through the semester, I decided to start simultaneously streaming to both Zoom and YouTube, just kind of see what would happen. And also because I was doing it because there was one particular student in the class who couldn't watch the Zooms because he didn't have enough bandwidth with his connection at home. And because you can stream to YouTube, it can adaptively change its bandwidth depending upon your connection. And so that was good for him. And then what I discovered was that people from all over the world were kind of tuning in to listen to my classes, and I thought that was really cool. So what we've got is some people on YouTube who are just watching, and they're not able to really interact with us except by using their text chat. But my focus is mainly on you, the Zoom students who are actually in my class. So for the Zoom students, this is being simultaneously streamed to YouTube. However, the people who are watching YouTube tend not to be my students, and so I have a button that I can press that will mute the audio and the video going to YouTube if anything gets discussed on the Zoom that is private to just the course, right? So if you have to talk about grades or policies at the school, or anything that the general public shouldn't hear, I will mute the YouTube stream so that they won't hear or see anything going on. So I can see you on Zoom. I can see your faces if you've got your camera turned on. I can see your names if you don't have your camera turned on. The people on YouTube can't see that. All they can see is just me, and they can see what's on the screen, but they can't see you. They can hear you if you talk, but they can't see you. So I just want to let you know that we are streaming it to YouTube, but I've taken some steps to ensure the class's privacy as much as possible. Okay? So, looks like some screenshots are coming in, so let me go and get those up on the screen and then we'll take a look at them. And in just a moment, I'm going to turn off the sound, but let me get this done here. Right. Hopefully also, if you're on Zoom, you'll notice I'm doing screen sharing in order to get my screen on the screen. But also, I want you to set things up so that in addition to the screen, you can also see me as a little thumbnail in a corner. So set that up so that you can see both me and the screen that I'm sharing, so that if I have to show something while I'm still screen sharing, you can see that. Okay, so what I'm doing is I'm pasting in the screenshots that you guys have uploaded, and I'll be with you in just a sec. Another little awkward pause as I get all this stuff on the screen. Oh, that one's really small. I mean, like, it's the screenshot is really small. If I can get that. Oh, it came out okay on there, right? All right, one more to do. Okay, let's take a look at these. So I think I got 1, 2, 3, 4. Oh, I missed one. Okay, so let's see what we got here. Oh, did somebody else post one? Oh, somebody else posted one. Let me get that one open. Okay, that should be enough. Okay, so here's what we got. The first one up here. This looks like it was written in Java. And it looks like It's pretty good. I don't see any major problems with it. We've got a class declaration here. We've got a main, and then a system.out.print, and then the text that we want to print. And the next one down here, this also looks like it was written in Java. Got a class declaration, got our main, here's our print, a few braces to end things up. So that looks pretty good too. Oh, this one here, up at the top, this was actually written in C. So this actually looks pretty good. Guess I would ask whoever wrote this one, why are you in this class? This is actually a C program here, so this looks pretty good. You'll notice that the C program looks very similar to the Java program. We've got a main here, although the declaration for main is a bit simpler. And then instead of system.out.println, we have just a single printf, and then the string we want to print. And then up at the top, instead of any imports, we've got something that looks like include. So this is a basic C program, and this will happen to work.
So that was mine, and I took a C++ class last semester. From the C++ end, but we didn't work very much with pointers and real low-level C stuff. So
okay,
here.
So you were hoping to get some of the more advanced stuff out of this, right?
Exactly.
Yeah. So you'll notice that C and C++ are very similar. In fact, just about any C program you can write will work with a C++ compiler. The reverse is not necessarily true. So there will probably be some things you need to unlearn when you do C, because C++ may have either made it easier to do something or may have actually made it harder to do something. So a good thing you're not taking the two at the same time.
Yeah.
I remember once when I was a lot younger, I think I made the mistake of taking tennis and badminton at the same time. Now, if you've ever played both those sports, you know they're both played with rackets, they're both played with a net, they're both played on a court. Tennis, of course, is played with a tennis ball, and badminton is played with those little birdies, right? And badminton is played mostly with the wrist, so you flick your wrist in order to hit the birdie, whereas tennis is more of an arm and a shoulder sport. What I discovered in messing with those two sports at the same time was I tended to hit the tennis ball like it was a birdie, and that would send the tennis ball clear into the next area code, like way over the over the fence and into the neighbor's yard. And so I had to learn very quickly that how to hit them correctly, but it was still really challenging to do both at the same time. This next one over here, this looks like it is written in Python. These greater than signs here are not actually part of the program. This is the program itself. It's just a one-line program, and then it just prints out the text that you want. And then we've got two more. I'm going to guess that this top one is Java also, although it looks like right here, normally there would be a public sitting in front of the class, but the rest looks okay. And then this final example down here, this is also Python. And since, and I'm going to guess, not only because it's one line, but also because the extension on the file is .py right there. Okay, so that's your C programs. That was a pretty simple one. It just simply prints out one line of text. And so let's now take a look at another program that I want you to write. So I want you to write a program, again, in any language you want. And you can either do it on a piece of paper, or you can actually type it up on your computer and then take a screenshot. And then I want you to print out, I will practice C every day, but I want you to print this out 20 times. I want 20 lines of this text on the screen. So go for that. And again, post your screenshots to the Zoom chat, and I will put it up on the screen here. Okay, so for those of you who are just tuning in on YouTube, so this is the new semester. It is spring 2022. This is my System Programming in C course. I have about 30 students, of which about 10 of them are on Zoom right now. And I'm speaking primarily to them because this is a class for them. But I'm also simultaneously streaming this to YouTube for anyone who wants to just watch and learn about C and writing systems programming in a Linux environment. So what we're doing right now is this is just the first day, and we're kind of just getting the ball rolling, and I'm having students write simple programs in any language they want, and then in a moment here we're going to compare that to the C version of the program. So maybe while we're waiting, if you're watching on YouTube, let us know where you are. What part of the world are you in? I already saw someone say that they're from Serbia. But where are you from? Some of the questions on YouTube are like, where do I sign up for this course? You don't. So this is just being simultaneously streamed from my regular course. The students who are on Zoom did sign up for the course and are receiving credit for it, but on YouTube I'm just doing this as kind of a freebie for anyone out there who just wants to tune in and watch this. We've got someone saying they're from Turkey. Another one from Oklahoma. New York. Russia. So cool. Everyone's tuning in from all over the place. It's funny, I say tuning in like it's a radio. It's not radio. I don't know what else word I should use. I should use a... like it's just watching, right? Pennsylvania? All right, let me get these screenshots in. They're starting to come in. Maybe while we're waiting, a little bit about me. So like I said a few minutes ago, I've been teaching this course for at least 12 years, probably longer. I've lost track. I've been teaching full-time at Sierra College for 20 years. And before that, I worked for the local IT industry. So I was a system administrator or a programmer. And then prior to that, of course, I was in college and graduate school. So I have a master's degree in computer science, which I got from UC San Diego back in the mid-90s. I started teaching, 20 years ago, so that'd be 2002, and that's what I've been doing ever since. So I kind of got hired on as a system administrator and programmer at kind of like the, as the .com industry was really ramping up back in the mid to late 90s. And then when it peaked at the early 2000s, that's when I jumped out of that and went into academics. Let's see, I'm pulling in some more of these screenshots. So I've got 3 so far. Oh, here comes another one. And hopefully we'll get maybe one more. Oh, here we go. Okay, let's take a look at these. So your assignment was print out the text, I will practice C every day, but 20 times. So you could write the program with just 20 print statements going down, but I wanted you to maybe use some kind of loop on that, because that seems like the easier way to do it. First program, this is C. And again, I can tell not only by the format of the program, but also, see right there that it says C. And this looks pretty good. So we've got a loop that counts from 0 up to 19, which is less than 20, and it prints out this text 20 times. And then this down here, this second one, this looks like it is Java. Whoops, I don't know why I wrote C there. And this one looks pretty good too. So we got a counter from 0 to 19 and a print within the loop. Here's another program that is also written in Java. And this one's got a main, we've got a variable which keeps track of how many times to print out. So I suppose if you wanted to print this out 100 times, you'd only have to change this number here. And we got a loop that goes from 0 up to that number of times and then a print. And this one down here is also Java. And it looks pretty good as well. Oh, someone said, forgot to change the text here. I didn't notice that either, but that's all right. Got the idea. You're using a loop. Now, up here, this is a Python program. Here's how Python does its loops. You got for and then a variable, and then you've got the starting number and the ending number, but you always do one more than the ending number. So this one counts from 1 to 20, stops at 20, and then we got a print within it. And then finally, this one here is also a Python program. And that works as well. So this counts x from 0 to 19, and then prints out this. That's good. Any questions about that? Okay, final program for you to write. Write a program in any language that asks the user for how old they are, and then it calculates their age if they were a dog, and then displays the result. Now, here in the United States, we have this like running joke that there's a conversion between human age and dog age, and you do that by multiplying by 7. So if a dog is like 10 years old, it's actually equivalent to being 70 in human years. So that's all it needs to do, is just prompt the user for their age, multiply that by 7, and then display the result. This program is going to be a little more complicated because now you need to print out a prompt, you need to get input from the user, do a calculation, and then display the result. Again, it's not very long, but there's more work to do. We got some people saying that they're from the UK and from Syria. So, very cool. We got people from all over the world who are watching. Now, I'll probably say at this point, some programming languages make a program like this fairly easy to do, and some it's not so easy to do. I don't know if you can hear that scratching noise. That's my dog down here on the floor, and he has decided to start digging a hole in the floor. Not sure why. Some dogs, they do that little turning around thing, you know, before they lay down, they turn around 3 or 4 times. This dog just like digs. I think he's digging a little hole for himself. Then he lays down in it. Well, how are you all doing on this? So if you're doing this program in a language like C or C++ or Python, it's probably pretty easy to do. If you're doing it in Java, well, let me put you out of your misery, right? Because in Java, well, you got to do something with make the scanner class, or if you're not using scanner, you've got to use buffered reader and an input reader. And then you've got to maybe convert from text to numeric, and maybe you're digging through some documentation because you're like, I don't remember how to do this from last semester. So let me just like stop you there. See, Java is a programming language from the mid-90s when the web and the internet were really first starting to take off. And so the designers of Java wanted it to be a language that kind of was the best of all sorts of different worlds. You had the world we were coming from, which was text-based input and output. And we're going into a world with web-based graphical input and output. So Java really was designed to do all of that. And the problem with doing all these things is it's not really good at doing any of them. I mean, it's okay, but it's not great. And so you end up having to do a lot of research in order to get it to do textual input and output. Or if you wanted to do graphical input and output, you've got to bring in all these Java libraries just to get it to do something fairly simple. And so Java is, to me, kind of like the Toyota Camry of programming languages. It's a nice general purpose vehicle. It gets you from where you are to where you want to go in relative comfort. It's not super fast, it's not super comfortable, but it gets the job done. There are certainly some things that Toyota Camrys are terrible at. Like they're not great at like hauling dirt. They're not great at hauling large things because they only have a small trunk, but they're good for hauling passengers around in relative comfort. C, on the other hand, is kind of like a utility vehicle, right? You can haul passengers. It can go relatively fast because it's small and nimble and light, and you can have it do a lot of things, but it's really more specialized, right? It harkens back from an era when textual input was the primary way to get data in and out of the computer. And so C doesn't do things like graphical user interfaces very well. It can be done, but it's not as easy as it is in something like Python or Java. However, it is super easy to do textual input and output in C. C++ is also kind of the same way. So I guess before I show you this program, let me go ahead and show you the other two programs. Now, somebody already posted them on the screen, but I'm actually going to type them in live on our development environment and then show you them being actually run. So this is our development environment. It's a very simple setup. I wanted to create a setup that did away with anything that you didn't need. So a lot of beginners who are learning to program want to jump right in with a professional development environment like Eclipse or Visual Studio Code or Visual Studio, the full one, and then you get overwhelmed by all these buttons and all these menus, 90% of which you don't need as a beginner. So I wanted to do two things. I wanted to make a development environment that beginners can use, and advanced programmers, but beginners primarily. And so I did away with all the stuff that you don't need. And also, I wanted an environment that you can use on the web. So there's nothing to install, nothing to maintain for you. That means you can do this course, if you're enrolled at Sierra College, you can do this course without having to have like a proper computer. You could do this on a tablet, you could do it on a Chromebook, you can do it even on a phone. I've had some students do it entirely on a phone. It's not fun, but it can be done. And so this is entirely web-based. We'll get into details about how to actually set this thing up and how to log into it next time. That'll be on Thursday, but I'm just going to show it to you right now. So right here in this area is where you type in your program. Down at the bottom is called the command line shell, and that is where you're going to issue commands to compile and run your program. And then finally, over on the left-hand side, we have a file browser. This is where you're going to see your files. So I'm going to start out by creating a new file, and let's do that first program, the one where we said I love pizza. Give it a name, and in C, you're going to give it the extension .c. So your C source codes are going to have the .c extension on them. And then this program is pretty short. You put this thing that looks kind of like an import statement at the top, but it's called an include directive. You've got a main, and so Java also has a main, but in C, the declaration for main is a lot simpler, at least for now. It just says int, and then main, and then two parentheses. Braces to delimit the beginning and end of the program, and then inside, just a single statement to print out the text that we want. So one of the nice things about the C programming language is there's not a whole lot of extra stuff around your program. You can get to the meat of your program very quickly. There's only one include you have to put at the top, and then you put your declaration for main, and then you're diving right into the program. There's not a whole bunch of imports and classes and public and private stuff. You just dive right in. So now I'm going to save this. You can see over here on the left-hand side, I've got a file called pizza.c. And then down here in my command line shell, I'm going to type in the command to turn that source code file into the executable that can run on the computer. So the command we're going to type in is clang, stands for C language, the C language compiler, pizza.c, and then press enter. So 2 words, clang, which is the name of the compiler, and then the program that we want to compile, pizza.c, and then press enter. And then it will create a file called a.out. This is the executable. And then to run it, we type in ./a.out and press enter. And it says, I love pizza. So this development environment, fairly simple. You've got an editor, a command line shell, and a file browser. It is running on top of a virtual machine. So there is a virtual machine running the Linux operating system, running on a server that we maintain and manage. And your development environment runs on top of that virtual machine. And the advantage of a virtual machine is that we can start it up and shut it down as needed. So when you log into our development environment, that virtual machine starts up, and then when you log out, that virtual machine shuts down. And so we're able to host 50, 60, 70 people simultaneously on one machine, just simply because not all of them are using the resources at the same time. All right, let's do the other program, which was the one to print out. I will practice C every day, but do it 20 times. Let's create a new file. I will call this practice.c. And it's going to start out the same way. Include standardIO.h int main, and then our loop for int I equals 0, I is less than 20, I++, your standard counting loop. And then we're going to print out I will practice C every day. Save it, and then compile looks very similar to the one above. Clang, and then the name of the file we want to compile. Now, if you don't have the Clang, if you're watching this and you don't have the Clang compiler installed, you can either install it on your system or you can use GCC instead. Run it by typing ./a.out, and then you can see that it's printed out that text 20 times. So it's about this time when you might be asking some questions, like what would happen if I do something? Like what would happen if I don't put this \n on there? And what is this thing for anyway? So in a textual output system like this, it's going to print this text out, and by print I mean displayed on the screen. It's going to print this text out, and then we need to issue essentially a command that tells the cursor to go down to the next line. And that's what this \n does, is it tells the system, when I'm done printing out this text, go to the next line. That's what the n essentially stands for. It stands for new line, create a new line. If I was to leave that out, and I'm going to save this, and then compile it again, because I made a change to the program, so I'm going to compile it again, and then if I run it, you can see that the text just gets all bunched together. So it prints out, I will practice C every day, and then the next one starts printing right after that. And then when it gets to the edge of the screen, over here on the right-hand side, it just wraps around to the next line. This is actually all one line of text. It's just wrapped around. So when you want to print something out, it's a good idea to put that new line character on there so that the cursor goes to the next line. If you omit it, and there could be reasons to omit it, like if you want to prompt the user and you want that cursor to be sitting right next to your prompt, then you shouldn't do the new line because you want that cursor sitting there. But most of the time you're going to want to put that there. And unlike in Java, where you have a print line method and a print method, in C there's just one. It's called printf, and you have to put the new line character on there for you. Well, you have to put that on there explicitly to make it go to the next line. So any questions about this program yet? So now let's do that dog ears one. It's going to start out the same way. Include standard io.h, so you can kind of start seeing some patterns here about how you start a C program. Now for this program, we have to do several things. We have to prompt the user to enter their age. And we're just going to use it using a print statement. Very simple. Then we are going to get input from the keyboard. And then we will do a calculation, and then we'll display the result. In this case, I'm not going to put the new line character on there, that \n, because I want the cursor to be sitting right next to the colon. Next, we want to get input from the user. That is done with a function called scanf. So printf is for displaying things on the screen, and scanf is for getting input from the user. We're going to do something a little strange here. Inside of the double quotation marks, I'm going to put %d. That means I want to get input from the user and convert it into a base 10 or decimal number. So the input is going to be a decimal base 10 number, and then I want to put that input into a variable that I'm going to specify. I'm going to call the variable age. When you're using scanf, you're going to put an ampersand, the and sign, in front of the name of the variable. And we also need to declare that variable before we do the scanf. So I'm going to go int age, semicolon. Now I need to convert it into the equivalent dog age. So I'm going to create another variable for that. And its value is going to be the value of age multiplied by 7, and I'm going to store that right away into the variable. I could separate this into two separate statements if I wanted to. I could declare the variable and then do the calculation, or I can combine them into one statement. Doesn't matter. And then finally, I'm going to display the result. Notice the printf statement here looks a little different. We have a %d sitting in the middle of that. That is a placeholder that tells printf that I want to insert the value of a variable here, and the variable is going to be a base 10 or decimal number. So it's the same %d that we got from scanf, telling it that the variable we're going to insert here is a base 10 or decimal number. And then after the string that we want to print out in double quotes, we put a comma and then the variable we want to insert there. So what printf is going to do is it's going to start here from the left-hand side. It's going to start outputting these characters to the screen. And then when it encounters that %d, it says, whoa, just a moment. I'm going to go and pull the value of this variable, format it as a base 10 number, and then insert it right where that placeholder is. And then it will continue printing out the rest of the text and then a new line. So let me go ahead and save this. And I'll just press enter a couple more times so I get my prompt back. I'm going to compile the program and then run it. And it says, please enter your age. So I'll type in something like 25. Oh, it said 25. What's wrong there? Now, I know what's wrong here, but I'll let you tell me what is wrong with my program. Why did it not print out 160 something, 150 something? Right, I should have used the dog age variable here instead of just age. So let me go ahead and make the change. I'm going to save this, and then because I changed the program, I need to recompile it. Please enter your age, 25, and then it says you're 175 years old. That's exactly what I wanted. Now this program doesn't do any kind of error checking. If I type in -10, it says I'm -70 years old, so that's okay for now. What I wanted to just show you was how relatively easy it is to display text to the user, get input from the user's keyboard, do a calculation, and then display the results. So do you have any questions about this program? Anything you want me to try? I'll try to explain it.
Can you maybe walk us through like a situation where you have a compile time error?
Sure. What kind of error do you want me to introduce into this program? What would be a typical error that you might make in your first C programs?
Misspelling.
Misspelling like a variable name?
Yeah.
So let's change this to Doge. Now this is why I like the Clang compiler instead of GCC. It gives great error messages. This error message is error, use of undeclared identifier. Now identifier is compiler speak for the name of something. It could be the name of a variable, the name of a function or method. Those are the two things, right? So when you see identifier, you should probably think variable. So it says use of undeclared variable Doge. Did you mean dog age? And then it points to where the error is, along with another note that says, oh, here's where dog age was defined. Is that the one that you actually wanted? So Clang is not only has detected the error, it has suggested a fix for you. You shouldn't always necessarily take the advice of the fix, but it's very good about identifying the error and telling you what it thinks you should have done. So one of the things I need to tell you is Clang's compiler error messages are really good. Please, please look at the error message and read it and maybe take its suggestion. I have a lot of students coming into my classes who don't pay attention to error messages. They have written their program, they compile it, and they sort of like acknowledge in their brain that there's an error message, but instead of reading the error message, they flip back to the editor and they stare at their program. And I come up to them and I say, and this is when we're in the classroom, I come up to them and I go, what are you doing? They're like, well, I'm looking for the error. And the first thing I ask is like, did you read the compiler message? Did the error message tell you anything? He goes, nah, the student invariably says, and I said he, but I don't mean necessarily he. Everyone does this. I said, They say, no, I don't pay attention to those error messages. I just look for the error. And after years of like wondering what's going through their mind, I started asking them, why do you not look at the error messages? And so let me ask you, people who are watching this, does this happen to you? Do you see that there's an error message and then immediately flip back to your source code and start like looking for the error?
I mean, it usually points me in the right direction. I don't just go searching for it.
Well, so you're actually looking at the error message, right?
Yeah.
Yeah. I know there's lots of students who don't. They just like, oh, it didn't compile. Let me go look at the program.
Okay. Because I was a little confused. I was like, why would you do something like that?
That's what I was wondering too. Anybody else? But John says, just run the program again without changing anything. It usually doesn't change anything, right? It usually doesn't act any different. But here the problem is it won't compile in the first place. So I finally sat down with my class one day and I said, what's going on? Why aren't you looking at the error messages? And they told me, a couple people finally raised their hand and they said, well, because the Java compiler's error messages are so terrible. You get an error message in Java and you can't tell what it means because it uses words you don't recognize like interface and enum. And then otherwise they're just totally incomprehensible. The beginner can't understand what those error messages are trying to tell you. And so I said, okay, that's understandable. The Java error messages are not great. The Clang error messages are much better. And if you can't get anything out of the error message, if you can't understand what the error message is saying, at the very least, look at the line number. This is the line number 13, character number 53. Line number 13 will at least tell you where approximately in the program you should focus your debugging. Don't just bring up the editor and try to start from the beginning and try to figure out what the error is. The compiler will tell you that it encountered an error around about line 13. So if you don't get anything else out of the error message, at least look at that line number so you can focus your efforts on that point. So line 13 is indeed where we had that error. And so I think you're going to find that Clang's error messages are really quite good. Sometimes they say something a little incomprehensible, but for the most part, for at least the beginner, it's great. When I first started teaching this class 12 plus years ago, GCC's error messages were almost as incomprehensible as Java's were. So they weren't that great. But I think because of the quote-unquote competition from Clang, GCC has really upped its error message game. And now their error messages are much better as well. So if you don't have the Clang compiler installed and all you have available to you is GCC, you can go ahead and use that. It won't be quite as good as Clang as far as the error messages, but it'll be pretty good. Yeah, John says, sometimes it's difficult to decipher what the compiler means. So at the very least, let's get the line number out of it. Okay, what else? What other error can we do? We could, a common thing is to leave off a semicolon. So let's try compiling that. And there it says error, semicolon was missing. Expected to see a semicolon there, and it points to where it thinks that semicolon ought to go. Another one might be, let's leave off this declaration of dog age. It says error, use of undeclared variable dog age. Here's where it encountered the error. And there's another one that says there's another place where it was used. In this case, it doesn't suggest a fix, but it does correctly identify that the variable hadn't been declared. And so you just need to put one in there. I'm just going to undo my change and put it back. Another one they might do is maybe instead, maybe I'll make this like a float, but I put a %d here, which means this is a base 10 integer. And here it says the format specifies type int, but the argument is of type float. So it underlines both the errors here. It says that this should have been a %f because it needs to match the type of this variable over here. However, it turns out our problem is this should have been an int in the first place. Oh, a question was, later this week, will we be walking through the first assignment? Yes, on Thursday, I'll show you how to get logged in. Actually, there's some videos online to show you how to get logged in, but I'll walk you through how to type in your first programs, get them compiled, get them running, and how to turn them in. Although I believe there are some videos on our Canvas site about how to do all those steps. Okay. Any questions? I love the questions. The questions are almost like the best part of the course because I can't anticipate everything that you might ask. I've been programming for so long. I've, in some cases, forgotten what it's like to be a beginning programmer, and so I really, really like the questions that you ask because they kind of reset my mind back to, oh yeah, I need to be thinking about those things. Okay, so let's start talking about differences and similarities between a programming language you already know, like Java, and the one that we're learning, C. The syntax of both languages are very similar. If you kind of like look at a C program and you look at a Java program, they can be hard to distinguish from each other. They have many of the same superficial syntaxes, like semicolons at the end of statements and braces to delimit the beginning and ends of blocks of code. A main, they both have a main, although the main in C looks a little bit different than the one in Java, but they both have a main. The way you declare variables is the same. The way you do things like loops and conditionals, exactly the same. So the nice thing about learning Java first is you can take a lot of that syntax knowledge and bring it over to C. It's just that it's a bit simpler in C. And a lot of people say, like, well, C looks just like Java, but actually it's the other way around. C dates back from the 1970s and Java dates back to the 1990s. So Java came 15, 20 years after C did. So it's proper to say Java looks like C, because it took a lot of the syntax features of C and C++, and then used those as well. In fact, that was one of the design criteria for the initial programmers of the C compiler. They wanted to make a language that C++ programmers would feel comfortable in. They felt that C++ had grown bloated and huge and was too complex. And so they wanted to make a language that was object-oriented like C, but didn't have a lot of the extra features that they thought they didn't need. So they stripped down C++ to what they thought were the bare essentials for doing an object-oriented language. And then that's what Java became. And so the syntax of Java looks a lot like the syntax of C++ because they wanted to give C++ programmers that warm, fuzzy feeling when they converted their code over. So in Java, you've got the basic int data type. Now in Java, the integer is defined to be a 32-bit quantity. The Java specification says ints are 32 bits. In C, however, the integer data type is dependent upon the processor you're running it on. If you're running on a a modern machine, it'll be 32 bits, just like it is in Java, because that's the most natural data size for an integer. Most modern processors use 32-bit integers. However, some other processors, some older ones, might use 16-bit integers. Some might use 8-bit integers. Some might use 64-bit integers. So in the C programming language, an int is defined to be whatever size is most natural for the processor. For ours, the one that we're going to be using in our development environment, it's 32 bits, so it matches what Java is. But just be aware that if you were to take your program and port it over to another machine, another different architecture, the integer might be a different size. Java has float, and C also has float. In this case, they're probably identical. Java has double, and C also has double. Java has, well, I'll do char. C has no direct equivalent. The char, or character data type, in Java is designed to hold a single Unicode character. Unicode is the international character set that encompasses not only the standard ASCII characters, A to Z plus some symbols and numbers, but also all those extended characters like foreign symbols, Chinese, Japanese, Korean characters, emoji symbols. Those are all in the Unicode character set. And Java predates all of that stuff. And so the character data type in, I'm sorry, not Java, C predates all of that stuff. And so the character data type in C only holds a single ASCII character, whereas the character type in Java holds a Unicode character, which means it can actually be larger than a single byte. It ranges from 1 up to, I think, possibly as large as 6 bytes. So Java also has the byte data type, which is defined to be an 8-bit quantity. And that's essentially what the char is in C. Okay, so Java has byte, which is an 8-bit quantity, and C has char as its 8-bit quantity. However, in C, a char can also hold a number. And in fact, char always just holds a number. It's just that when you display it on the screen, it gets displayed as a character. So really, this is a 0 to 255 quantity, an 8-bit quantity. Java has Boolean, and C has no direct equivalent. At least not natively. That's not one of the primitive data types in C. Use int instead. So C is kind of unique. Not unique. Java is kind of unique in that it has this Boolean data type. And the Booleans are used for things like the ifs and the conditionals, right? So if x is equal to 5, that results in a Boolean. It's either true or false. In C, you just use an integer for that. So 0 means false, and anything other than 0 means true. Okay, so let me say that one more time. 0 means false, and anything other than 0 means true. That means a negative number is true, positive number is true, a million is true, negative 2 billion is true, even floating point numbers. 0 is false, and anything other than 0 is true. So there's no direct Boolean equivalent in C. What else does Java have? Oh, Java has string, And string is actually not a primitive data type, it's a class. C has no direct equivalent. There's no built-in data type called string. You're going to use a character array instead. Let me look up my list here. Okay, I've covered most of them. There is long, which is 64 bits. C also has long, which is also 64 bits. Java has short, which is 16 bits. And C also has short. Actually, let me back up and say, in C, the long is also processor dependent. It's defined to be twice as big as an int. So whatever your int is, the long is twice as big as that. So on our processors, the int is 32 bits, so the long is going to be 64 bits. And likewise, the short is defined to be half the size of an int. So on our systems, again, the int is 32 bits, so the short will be 16 bits. In Java, however, it's baked into the programming language that a long will be 64 bits and a short will be 16 bits. Okay, so that's it for the basic data types that we're going to focus on in this course. Now, someone in the YouTube chat said, what about the auto keyword? That's from C++. So auto is actually not a data type. Auto is a pseudo type. If I'm using the correct word there, it means that the compiler will try to figure out what data type it's actually supposed to be. So you can say something like, for auto, I equals 0, semicolon, I is less than 100, semicolon, I plus plus. And based upon the context, we'll infer that you probably want that I to be an int. Or maybe later on you could say like auto prompt equals and then quote unquote hello. And then we'll figure out, oh, it probably wants that to be a character array. So it will replace the word auto with the actual data type. It infers from your program what the data type ought to be, what it thinks it ought to be. Sometimes it makes a good guess, and sometimes it makes an incorrect guess. So auto is just a placeholder for trying to get the compiler to figure out what the data type is. So if you can't be bothered to like figure out what the data type is supposed to be, you can throw auto in there, and then it'll figure it out for you. I'm not a big fan of that, but some people are. Okay. So we're almost at the end of time here, so let me talk very briefly here about the way this course is going to be assessed and graded. So we're going to have the usual assortment of programming assignments. There's also going to be discussions and quizzes for you to do. But I'm going to be using a technique called ungrading in this course. That means that I'm not going to be assigning scores for every single little thing that you do. Instead, I'm going to just mark an assignment or a quiz or a discussion as being either complete or incomplete. Complete means you met the specifications for the program and it is done to satisfaction, right? It's good enough. It doesn't mean it has to be perfect. It just has to be good enough. There's just one small little problem with it. Like, you know, it works. It does the correct calculation. It's just there's one little thing that's wrong with it, but it doesn't impact the overall program. You know, I'm just going to mark it complete. I'm going to say that's good enough. Move on. Or if I think that the program doesn't meet the criteria for satisfactorily finishing the program, I'm going to mark it incomplete, and then send you feedback about what you could do to improve the program. And then I would like you to rework the program and turn in it again so that you can earn that complete on it. And this can happen as many times as it needs to do in order for you to get the complete. So you can decide for yourself, do I want to put the time into fixing the program and change it to a complete, or do I just need to move on and I'll leave it as an incomplete and then I can do something else? So my overarching goal in doing the grading like that is to take away from you the pressure of having to turn in a perfect assignment and earn like a 10 out of 10. Because me as a teacher, and I can tell you over the past 10, 15 years, I've come to like hate grading more and more and more, right? I just sit down and go like, oh, I gotta do this. And part of the reason is because I might score an assignment out of 10, but if it's not perfect, I have to give it a lower score, maybe 9.5 or 9. And then I have to justify why I took off half a point or 1 point. And sometimes those reasons can be kind of arbitrary. And, I know you don't like that because it feels like, well, this person did the same thing and he got a 8 out of 10 and I did it and I got a 9 out of 10 and I don't understand why the scoring is different. And also some people turn in an assignment because they feel rushed, right? You've got this deadline coming up and you have to turn it in, you have to get something in, and then you get feedback where you get a score on it and you go like, well, I know I got a 7 out of 10 because I just wasn't able to put a lot of time into it. So I want to take that pressure away from you. If I'm not going to give you a grade on an assignment, it also means I'm not going to penalize you for turning an assignment in late. If the due date for an assignment comes and goes and you haven't got it done, don't sweat it. Work on it this weekend. Get it in. Please try to get it in, in a reasonable amount of time. Don't wait until the very last week of the semester to turn all your stuff in, because if you do that, not only do I have to do a lot of work, but I also can't give you honest, authentic feedback on your assignment. I just have to rush through it. And then the last reason is I know that some of you receive a score on an assignment, and at that point, you're done, right? I got the score on the assignment, I have to move on. By giving you a complete or incomplete, I'm giving you the opportunity to redo the assignment as many times as you need in order to complete it to yours and my satisfaction. So in many ways, this is kind of like the real world. If you're working at a restaurant and your boss says, go clean the tables, he or she doesn't come back later and say, oh, you earned a C on that. Or you got a 7 out of 10. They don't hold up a card and tell you what your score was. They just say, hey, you didn't finish, right? Some of the tables are still dirty. Go do it again. Or they say, oh, looks good enough. Go back and do something else. Right? They basically give you a complete or an incomplete on it. So I'm doing this kind of as an experiment. This is my second semester doing ungrading. It worked out really well last semester. The biggest problem was that some students procrastinated. They put it off until much later in the semester because it was easy. There were no due dates. And so I've made a couple of changes in order to try to head that off. One is I've set up the grade book so that it automatically gives you an incomplete if the due date passes and you haven't turned anything in. I want you to be aware that if you see that incomplete, it doesn't mean you can't do the assignment. It's just kind of like a little notice to you that, hey, you're maybe falling a little behind and you need to work on that assignment. If you see that incomplete, be aware that you can still turn in the assignment. Even if it's late, there'll be no penalty for doing so, but you'll just get a little notice that you haven't turned anything in. I'll also be doing a periodic check-in with you just to see how you're doing. If we notice that maybe midway through the semester, you're falling behind on some of the work, I'll send out a little note that says, hey, it looks like you're falling behind a little bit. Is there anything I can do to help you kind of pick up the pace a little bit? Okay, so we'll get a chance to talk more about this ungrading thing over the next couple of weeks. I know there's already a discussion on Canvas for you to participate in and give me your feedback and your thoughts on the ungrading technique. So please do that within the next week or so. I guess I'll end up with one more thing, which is what kind of topics are we going to cover in this course? So this is a course about the C programming language. I can teach you the syntax of C pretty quickly. It's very similar to Java. All we got to do is strip out some of the complex bits. But so the syntax is very simple. I could teach you that in like, pretty quickly, 2 or 3 weeks. And so there's all this other stuff about programming that I think is important. Things like the standard library, getting input and output from the user, network programming. How do you send data across the internet to other computers? Memory management. I feel a little pressed for time, so I'm not writing these things down on the screen. I'll just focus on me. So process management, memory management, network programming, I already said that, standard library, and then plus tools that professional programmers use to make themselves more productive. Things like version control systems, collaboration tools, make files for automatically building programs. So all this stuff that I think is important to learn as programmers, but are not necessarily the C language itself. And we're also using a Linux environment because when you go on to another institution, they may expect you to be able to find your way through a command line environment to run and compile your programs. It also allows us to really focus on the C language itself and not have to worry about things like graphical user interfaces and making things look pretty. So we're using a programming language environment called Theia, T-H-E-I-A. It's an open source programming environment that looks a lot like Visual Studio Code. And in fact, one of its design goals is to be a clone of Visual Studio Code that runs entirely in the browser. So Visual Studio Code has to run on your computer, but Theia can run on a browser. And so we host it on one of our servers, and if you're enrolled in my course, then you get access to it. It's not like a standalone product. You can't just like download it and run it on your computer. It has to run within a framework. So you've got to like load it into a web page or run it in a Docker container or something like that. So I guess the closest equivalent to you, if you're following along on YouTube or something like that, is just go ahead and use something like Visual Studio Code and it will look almost identical. I think that's about it for now. We've hit 11 o'clock, so this is normally when we would finish doing our sort of lecture. On Thursdays, after our 11 o'clock lecture, we would take a break and then go into what we would normally call our lab session, which is where we go over the assignment and I answer any questions you have for it or walk you through the assignment. So that's what we'll be doing on Thursday. We'll be writing our first C programs and I will walk you through setting up and logging into our environment, writing your first C programs. So I've done a lot of talking. How about you? Do you have any questions for me before we call it a day for this class? Yep. I'm glad you thought I explained things really well. I thought I was talking a little fast at some points. And if you have any questions about some of the things we talked about today, then hold on to those questions and we'll come back on Thursday and we can talk about them some more. So it's really what I want to do with these live sessions is answer your questions, let you kind of guide where things go. If I just wanted to deliver information to you, I would just record a bunch of videos and have you watch it. But what I've heard from other students is they really appreciate having these live sessions because they might think of a question kind of in the moment, and the ability to just ask that question and get it answered right away rather than having to send an email to the teacher or post on a discussion board really helps their learning. The next class will be Thursday, same time, 9:30. If you want a different experience, a different class, on Mondays and Wednesdays, I'm also live streaming my Discrete Structures course, which is a course about the intersection between math and programming, the kind of the theoretical foundation for a lot of the topics you get in a programming course. So that'll be on Mondays and Wednesdays, 9:30, and then Tuesdays and Thursdays, 9:30 is this course. Okay, don't have any other questions, so why don't we wrap this up? Now, at 11 o'clock, I would normally go into my student hours or office hours. So if you have any questions, you need to add the course. These are for people who are at my institution. So if you need to add the course, you've got questions about the way the course is being run, then you'll find the link to that Zoom session on our Canvas site. Just click on that, and I will be over there in just a minute after we wrap this up. Okay, so hearing nothing else, I hope you all have a good day. And I will see you
Take care.
on Thursday.
Thank you.
All right.
See you soon.
Thanks. Bye-bye.
Bye-bye. Now, what invariably happens is I have to end the Zoom session, and then I have to go and end the YouTube session. So I get a few minutes to talk to the YouTube folks. And boy, you posted a lot of chat messages. There was a question from a while ago. It says, is there a try parse like method to make sure the user enters a valid number, and if the conversion is successful, then converts the user's input into an int? No. However, scanf will kind of do that for you. If you tell scanf, I want to type in an integer, and the user actually types in a word, then the conversion will fail, and you'll get an error code sent back to you. And the error code comes in the form of a return from the function. So I'm just calling the function. I'm just saying scanf and then the prompt and then the variable name. The scanf and then the format and then the variable name. However, there's also a return code there. And if you want to do proper error checking, you'll check the value of that return code. And if you see that it is issuing a return, an error number, then it tells you that something went wrong with the conversion. It doesn't tell you what exactly went wrong with the conversion, but something went wrong with the conversion, and you need to do something about it. And then there's some other kind of minor hiccups with that, which is, well, what happens to that data that the user typed in? Does it get thrown away? Can I get access to it? And that's where things get a little bit sticky. So for now, I'm not worrying about doing things like validating user input to make sure they're the correct type. We're not going to worry about that for now. We got bigger issues to work on. What else we got here? In Java and C#, sometimes the messages are quite verbose and sometimes don't seem related to the first exception that you get. Yeah, that can be a problem, that the compiler doesn't throw an error until it realizes that something has gone seriously wrong. In other words, you may have a line of code that has an error on it, but to the compiler, maybe it's syntactically correct. It's an error because ultimately it won't make your program compile, but at the moment, this line is correct enough to slip past the compiler. And then it doesn't notice that things got out of sync, maybe until a few lines later. Like that could happen if you forget to close the quotation mark on your string. So you open it over here, and then you got this long string, and then you forget to close it. Well, the compiler is not going to notice that that's a problem, because if you omit that closing quotation mark, then it thinks that all the lines below your program are also part of the string. And so it just happily sucks up those lines and builds a giant string. And then when it finally encounters another quotation mark, then it goes, that's the end of the string right there. And then the characters after that string now it goes like, well, what the heck is this hello thing sitting there? And then it goes, oh, there's an error here. The problem was actually you didn't close the quotation marks, but it didn't notice until a few lines later when it encountered another quotation mark. So Clang seems to be pretty good about that it goes like, you missed a quotation mark, you probably missed it here. Not sure, but you probably missed it here, and it points to that location. Scrolling through all the chat messages here. Oh, no Boolean data type. Yeah, in C, there's no explicit Boolean data type. You just use integers. There is, in one of the things that you can include in your program, there's a file called standard boolean, stdbool.h. And if you include that in your program, then it gives you a, I think it's just bool, data type, which underneath the hood is just an integer. But at least it gives you something that looks like a boolean. But it really is just a number. There's a question. How can we deal with very big integers like n factorial, when n is greater than 13, when we have just 32 bits? Well, you can eke out a little bit more precision by using something like a long. That doesn't get you a whole lot more as far as being able to compute factorials. If you want to go really big, then you need something like an arbitrary precision integer library, of which I'm sure one exists out there. But it's called arbitrary precision integers. And that gives you a whole bunch of functions, like you could do a multiplication function. You can't just use the standard operators. So now you have to use function names. But it probably gives you a way to compute factorials. But in that case, the number can be really huge. I think I'm almost at the end of the messages here. Oh, we got one person that says they're taking the C programming course also, but from a different instructor. So go ahead and watch mine. Watch both, and then you'll get like 2 takes on the same material. So I have no problem. Yeah, come on and join and watch it. It'll be just fine. Okay, I've reached the end of the chat messages, and I need to go now and see if there's any students waiting for me in my student hours. So to the YouTube folks, thanks for joining in. Again, we'll be back on Thursday at 9:30 Pacific time, same time. And we're going to start introducing more of the basic syntax of C, so enough to be able to write simple programs. Not much more complicated than the ones you just saw today. Display things on the screen, get input from the user, do computations, display the result. Really basic stuff. Loops, conditionals, all the stuff that you should know coming into the course. Just kind of like how to write simple programs in C. You've already written simple programs in Java or Visual Basic. So, basic stuff. Let's see. When you use scanf, is there a reason why you got the variable via reference? You mean like putting the ampersand on there? I'm going to leave that as, for now, just a recipe that you have to follow. So when you use scanf and you want to put the result into an integer or a float or a double, you need to put the ampersand on the front. We'll explain later what that means and why you might want to omit that, but for now, put it on there. All right, folks, thanks for watching, and I will see you on Thursday. And maybe next time we'll be able to keep up more with the chats that are coming in. Boy, I've never seen so many chat messages. Last semester when I was doing this class, I got like half as many. So this is great. Lots of questions in there. I'll have to focus on them a little bit more and answer the questions as they come in. Okay? So have a good day, everyone. I'll see you next time. Bye-bye.